Dear students, welcome to this session. In this session, we are going to solve some problems on zero initial velocity for one-dimensional wave equations. Those who don't watch the procedure for zero initial velocity problems, go to the playlist and watch the video and come back here. Because in this video, I am going to do FFS, little fast forward speed. Because once you know the procedure, it is going to repeat here. So I don't want to keep on telling all these things in the video. Give an example. A uniform string is stretched and fastened to 2 points apart. So the length of the string is L. Motion is started by displacing the string. So that means displacement is given. Motion is started by displacing the string into the form kx L minus x. So initial displacement is given and then releasing it from its rest position. So that means it was initially at rest. So there is no velocity. Therefore, it is a zero initial velocity problem. Now, step 1. I have to draw the figure. So just draw the string. It has two ends a comma b. One end x equal to 0, other end x equal to L, and the displacement is y of x comma t. Now in this end, y of 0 comma t equal to 0 and y of L comma t equal to 0. Next, wave equation. We have to write the wave equation y double t equal to a square y double x, where a square is t by m. First step, diagram. Second step, two informations, wave equation. Third step, out of three possible solutions, the most suitable solution is this. Let us take it as equation 1. Step 4, we have to write the boundary and initial condition. From the figure, we can write this two boundary conditions. And since the problem is zero initial velocity problem, I'll write yt of x comma 0 is equal to 0 as my third condition. Finally, it has displacement. As I said in the procedure, whatever it is, simply write it as f of x. At the end of the problem, we can see what is this f of x given in the question. Next, take this equation, apply 1 in 1, we get a equal to 0. When you substitute a equal to 0 in 1, we will be getting equation 2. That is b sin lambda x, c cos lambda at plus d sin lambda at. Now, apply 2 in 2, we will be getting lambda is equal to n pi by L. So substitute lambda equal to n pi by L in 2, we'll be getting the new equation. Take it as 3. Now my third condition is yt of x comma 0 is equal to 0. So we need the derivative. Differentiating 3 partially with respect to t, will be getting this equation. I'm considering this as 3 star. Now apply the third condition in 3 star. We will be getting this, and we have the argument d equal to 0. Now substitute d equal to 0 in 3. We will be getting y of x comma t is equal to bc sin n pi x by L cos n pi at by L. We are going to consider bc as directly bn, and always equation 4 is the most general solution, where bn is equal to capital BC. Now apply 4 in 4. Then cos 0 will become 1 and y of x comma 0 is f of x. Now that is nothing but my question. In my question, the displacement is given as kx L minus x. Now it is very tough for integration. So I am multiplying this x and make the problem simple. I am going to write it as k into Lx minus x square. Now it looks like half range Fourier sine series, where f of x from the question is k into Lx minus x square. Now we know the Bn formula. Substituting this, Bn is equal to 2 by L, 0 to L, k Lx minus x square sin n pi x by L dx. Now we have to apply Bernoulli's formula to find the Bn. Since the highest power of the function f of x is 2, we will be getting 3 terms. So let us consider one by one. I am taking this k outside. Now Bernoulli's formula, integral u dv is equal to uv minus u dash v1 plus u double dash v2, etc. Where u is my diminishing function, that is Lx minus x square. U dash is L minus 2x. U double dash is minus 2. U triple dash is 0. Similarly, dv is equal to sin n pi x by L. V is going to be minus cos n pi x by L divided by n pi by L. V1 is minus sine n pi x by L n pi by L square. I'm integrating this. Do you understand? Then V2 is equal to sine integration is minus cos, minus into minus plus. It is going to be cos n pi x by L divided by n pi by L whole cube. Now we have to map uv, u dash v1, u double dash v2, and all the remaining terms get 0. Now bn is equal to 2k by L. The first term is Lx minus x square minus cos n pi x by L divided by n pi by L minus L minus 2x minus sine n pi x by L divided by n pi by L whole square. Then the third term is minus 2 plus cos n pi x by L divided by n pi by L whole cube, and my limits are 0, L. As I said, by seeing the problem at the limit 0, L, whenever you see sign, put directly 0. So the second term diminishes. Now see this term. When I substitute my upper limit, it will become L square minus L square. Similarly, when I substitute my lower limit, it will become 0 minus 0. So both the terms, it is going to be 0. Only the third term survives. Simplifying the third term and bringing the denominator to numerator, we get this. Now 2k by L minus 2L cube divided by n cube pi cube. When I apply upper limit, it will become cos n pi. My lower limit is cos 0. Here L get cancelled. Minus 4k L square by n cube pi cube. We know that cos n pi is minus 1 whole power n minus 1. If I multiply this minus inside, I'll be getting by Bn. So my Bn is 4k L square divided by n cube pi cube 1 minus 1 whole power n. Substitute this Bn in equation 4. We'll be getting the most general solution for the given problem. Since 4k L square by pi cube are constant, I took outside. Hope you understand. Let us go into another problem. A tightly stretched string with fixed ends x equal to 0, L initially at a position. So that means initial displacement is given y0 sine cube pi x by L. It is released from the rest. So they don't speak anything about the velocity. That is, my initial velocity is 0. Therefore, the problem is 0 initial velocity problem. And very good thing, when you see a problem with a trigonometric function, never miss this problem, because if the function is going to be like kx into L minus x, x square, etc., we have to do integration. If it is a trigonometric function, we don't want to do integration. We don't want to convert into half range Fourier sine series. Nothing. We are going to use the comparison, and we are going to solve the problem in a simpler way. So as usual, diagram we can check from the previous problem. Wave equation. We have y double t is equal to a square y double x. Alpha a square is equal to t by m. The most suitable solution, I am taking it as equation 1. Then the boundary conditions are y of 0, t equal to 0. Y of L, t equal to 0. The third condition is 0 initial velocity. Then fourth condition is y of x, 0. That is my f of x. Here it is y0 sine cube pi x by L. So I don't want to worry about it. I just keep it as f of x. So take equation 1. 1 in 1, we get a equal to 0. Substitute a equal to 0 in 1. We'll be getting new equation 2. Apply 2 in 2. We'll be getting lambda equal to n pi by L. Substitute lambda equal to n pi by L. We'll be getting a new equation. Take it as 3. But my third condition is yt of x, 0 equal to 0. Therefore, I cannot apply in 3. I am differentiating 3 partially with respect to t. I'll be getting the new equation 3 star. And I am going to apply 3 in 3 star. When you apply and simplify, you will be getting like this. And from this, we get d equal to 0. Substitute d equal to 0 in 3, will be getting this. Always, as I said, my equation 4 is the most general solution. So BC equal to Bn, I'm going to assume. Therefore, my MGS is going to be y of x, t, summation n equal to 1 to infinity, Bn sin n pi x by L, cos n pi at by L. Take it as equation 4. Now, apply 4 in 4. Or we don't want to worry about the function. just apply 4 in 4. Cos 0 will become 1. Will be getting like this. Now we know my function f of x is y naught sine cube pi x by L. When there is a trigonometric problem, don't try for integration. Try to use trigonometric formula to simply solve them. We know that sine cube theta is equal to 1 by 4 3 sine theta minus sine 3 theta. I am going to apply this for the given problem. So my f of x is y naught sine cube pi x by L. I am going to apply this formula y naught by 4. We will be getting 3 sine pi x by L minus sine 3 pi x by L. That is my LHS. My RHS I am going to expand. Now my f of x is y naught sine cube pi x by L. Now applying the formula, we will be getting y naught by 4 3 sine pi x by L minus sine 3 pi x by L. Because of the formula, sine cube is equal to 1 by 4 3 sine theta minus sine 3 theta, and right hand side remains as usual, bn sine n pi x by L. Now I can expand my right hand side also like this, b1 sine pi x by L, b2 sine pi x. Now multiplying y naught by 4 in the left hand side and expanding the right hand side, will be getting like this. In the right hand side, when I put n equal to 1, I will be getting b1 sine pi x by L, b2 sine 2 pi x by L, b3 b4 etc. It goes on. But you see in the left hand side, I have only sine pi x by L, sine 3 pi x by L, and I don't have any other term. So mapping this left hand side and right hand side, I will be getting 3 y naught by 4 is my b1 and minus y naught by 4 is b3. Now here we have b2. I don't have terms here. That means b2 equal to 0, b4 equal to 0, etc. All the other values are 0 except b1, b3. That is what the idea we get from this equation. Now substitute b1, b3 in equation 4. But 4 is MGS, my most general solution. Y of x comma t is equal to summation n equal to 1 to infinity bn sine n pi x by L cos n pi at by L. Here only two values survives. That is my 1 and 3. If I put n equal to 1 and 3, I'll be getting b1 sine pi x by L cos pi at by L. Similarly, b3 sine 3 pi x by L cos 3 pi at by L. All the remaining terms are 0. Now substitute the value of b1 and b3 will give the final solution. So don't miss this trigonometric problem, because we don't do any integration. Just by comparison we'll finish the problem. See the typed version. This is my final solution. Thanks for watching, and I think I make the video very simple for you. Subscribe, share to your friends. Any doubts you post in the comment box. We'll try to help you. Thank you. Good luck for your exam. See you in the next video.